Chapter 5 is on linear equations in two variables. Recall that we've seen from a previous section that if I have an equation that's written in the form y equals mx plus b, I can identify the slope and the y-intercept of this linear equation. The slope is the m value, the coefficient of x, and the b coordinate is part of the y-intercept. So if I want to identify the slope and y-intercept for each of these equations, part A, y equals negative 2x plus 4, the coefficient of x is negative 2x, so m, the slope, is negative 2, and the b value is 4, which means that the y-intercept is the ordered pair 0, 4. In part B, I want to do the same thing. I want to be able to identify the slope and the y-intercept. However, the y has not been solved for in this equation. I cannot find the slope or y-intercept if the equation is not in the correct form, if y has not been solved for. So what we're going to do first is divide both sides by 2 to get y by itself. This equation is now y equals 3 over 2, 3 halves, x. Y is now by itself, so we can say that the slope is the coefficient of x, 3 halves, and the b value, there's nothing added on to this equation, so the b value is 0, which gives us a y-intercept of 0, 0. Our note here, before we can determine the slope and y-intercept of a linear equation, we must solve for y, i.e. putting the equation in slope-intercept form, y equals mx plus b. In example 2, we want to determine the slope and the y-intercept. These equations have not got y solved for us, so we're going to do that first. And once we have it in slope-intercept form, we're going to graph the equation. So I want to solve for y. So the first thing I need to do is move the 2x. So we're going to subtract 2x from both sides. That leaves us with 5y equals, now 15 minus 2x, these are not like terms. This is just a constant, and the x term is an x term, they're a variable term, so they're not like. So I can't subtract them. I'm going to write it as 15 minus 2x, or, because we usually like to write the x first, mx plus b form, write the negative 2x first and the positive 15 second. Continuing on, we need to solve for y. To solve for y, we're going to need to divide both sides by 5. When you divide both sides by 5, you divide the entire side by 5. But you can distribute that division. So you're going to distribute the division so that each part of the right-hand side gets divided by 5. So what that's going to look like is negative 2 fifths would be the coefficient of x now, taking negative 2 divided by 5, plus, and then 15 divided by 5 gives us 3, once we distribute that division. Alright, so for this equation, we have a slope m of negative 2 fifths, and we have a b value of 3. A b value of 3 is going to tell us that the y-intercept is the ordered pair 0, 3. We want to graph these things. So to graph, I'm going to use my y-intercept first, 0, 3. Put my dot there. And then we want to go down 2 and over 5 for the next point. That's our slope, negative 2 fifths. Don't forget you can go in the reverse as well, up 2 but back 5. Up 2 and back 5. And let's connect these. So there we have the graph of this equation. Take a look at the next one. Alright, my goal, I know, is to get y by itself. In this situation, since I have so much on the right-hand side, let's go ahead and move the y term to the left-hand side. That'll leave the x's and the 6 on the other side. Just move the y. So to do that, because the y is a negative 3y, we're going to add 3y to both sides. When you have 0 plus 3y, you have just 3y equals our x minus 6. We're on our way to having y by itself. All we need to do now is to divide by that 3, both sides of course. So y is going to be equal to, and let's distribute our division again. Both parts of the numerator get divided by 3. The current coefficient of x is 1. Divided by 3 is going to make that 1/3 x minus, and 6 divided by 3 is 2. So for this equation, my slope is going to be 1/3, and my b value is -2, which gives us a y-intercept of 0, -2. Let's graph those things. 0, -2. Got my dot there. And now my slope was 1/3, so up 1 over 3. And we'll keep going up 1 over 3 till we reach the end of our graph. Now we'll go in the reverse direction. Down 1 and backwards 3. Down 1 and backwards 3. Down 1 and backwards 3. Also a slope of 1/3. And now we will connect. So as you can see, this is what the graph of that line should look like. The next page is going to talk about intercepts. Intercepts are points where the graph intersects the axes. We've already seen these definitions. Now to find them, to find the y-intercept, we're going to substitute 0 for x and solve for y. Right? The y-intercept is the place on the graph where x is 0. There's no horizontal distance. So you're going to plug 0 in for x and solve for y. And the x-intercept will do the opposite. To find the x-intercept, you're going to plug 0 in for y and solve for x. So finding the intercepts is often used as a technique for graphing the equation. So let's look at the equation 4x plus 3y minus 12 and we'll find the intercepts. First we're going to find the y-intercept. So if I want to find the y-intercept, we're going to plug in x equals 0. So in the equation, if you have 4 times 0, that's 0, plus 3y minus, or equals, minus 12 equals -12. And then you want to solve for y. So 0 plus 3y is just 3y. Divide both sides by 3. Y equals -4. And so the ordered pair that we're getting here, since I knew that x was 0, y is -4, the ordered pair is 0, -4. Let's go ahead and graph that ordered pair, then we'll find our x-intercept. To find the x-intercept, we want to set y equals 0. And in the equation, if y is equal to 0, we're going to have 4x plus 3 times 0. So that's going to give us 4x plus 0 equals -12. And then we're going to solve for x, since 4x plus 0 is really just 4x, by dividing both sides by 4. That's going to leave us with x equals -3. And remember that that is really the ordered pair -3, 0, because 0 is the y value. So we'll go ahead and plot -3, 0. And if I plot just those two ordered pairs, it is enough to connect the line. You're going to want a ruler for this one to make sure that your line goes all the way through with just those two ordered pairs. You need to connect them and use a ruler to extend this through the page. So when your graph is finally complete, it should look like this, connecting our two intercepts and going all the way through both sides of the graph here. So this is one way of graphing that does not require I find the slope and the intercept. If I find the two intercepts instead, I can connect them and graph my line. Let's look at another example. We want to graph this line by finding the intercepts. So first of all, we're going to find the y-intercept. When I'm looking for the y-intercept, I know that 0 is going to be plugged in for x. So 2 times 0 is 0. Minus 3y equals 15. And that's just -3y. So I'm going to divide both sides by -3. We're going to get y equals -5. And the ordered pair was 0, -5. 0 being the x value, -5 being the y value. Let's graph that. Okay, and then we'll get our x-intercept. So for the x-intercept, we're plugging 0 in for y. So I'm going to have 2x minus 0 equals 15. 2x minus 0 is just 2x. So we're going to divide both sides by 2. And we get that x is equal to 15 halves. And so my x-intercept is the ordered pair 15 halves, comma 0. Now it's convenient to think about 15 halves as a decimal so I can figure out where that is on the graph. So I know that's about 7.5. So if I find out where 7.5 is on my graph, that's where I'm going to plot my x-intercept. And once again, we'll connect those to get the graph of the line. So your finished line should look about like this, going all the way through the graph and connecting the two intercepts. In example 5, we've got some equations that have approximate values as coefficients of x and y, some decimals. So we're going to find the approximate intercepts. We're going to round our coordinates to the second decimal place. All right, so let's find the y-intercept first. And I know that to find the y-intercept, I plug in 0 for x. So this is 0 minus 5.8y equals 23.6. 0 minus 5.8y is just negative 5.8y. So we're going to divide both sides by negative 5.8 to solve for y. Grab a calculator and do that division. 23.6 divided by negative 5.8 comes out as negative 4.07 if I round it to 2 decimal places. So this intercept is the ordered pair 0, negative 4.07. We're going to do the same thing for our x-intercept. When I want the x-intercept, we plug the 0 in for y. So here I've got 3.9x minus 0 equals our 23.6. 3.9x minus 0 is 3.9x. So you're going to divide both sides by 3.9 to solve. And you'll get that x is equal to 23.6 divided by 3.9, which gives you 6.05 if you round to 2 places. So the x-intercept is 6.05, comma 0. If I look for the y-intercept, I know I'm always plugging a 0 in for x. So y equals 0 minus 17.51, or y equals negative 17.51. Notice that this equation was already written in y equals mx plus b form, so I know that the number b is the y-intercept, but you can also see how that works out naturally as it being the y-intercept because that is what you get when you plug in 0 for x. So our y-intercept is 0, negative 17.51. We're going to have to do a little bit more work and grab our calculator to get our x-intercept. To get our x-intercept in this case, we're going to plug in 0 for y, and we're going to have 0 equals 2.46x minus 17.51. If I'm looking for the x-intercept, the variable that I'm solving for should always be x, and vice versa. For the y-intercept, the variable you're solving for is going to be the y. To solve for x here, we want to first get rid of the negative 17.51, so we're going to add that to both sides. Add 17.51 to both sides. That's going to give us 17.51 equals 2.46x. And then we know that if we want to solve for x, we're going to divide by the 2.46 both sides. Grab a calculator and check that division. 17.51 divided by 2.46 is going to give you about 7.12 if you round it 2 decimal places. So my x-intercept is 7.12, 0. Let's check out the next page. In example 6, we want to finish the following table for the equation and then graph the equation. So in our table, we want to plug in a value of 2 for x, plug in a value of negative 2 for y, and then we get to choose our own ordered pair for the third one. So let's do some of those calculations over here. If I plug in the value x equals 2, we're going to have 3 times 2 minus 5y equals 1. So that's 6 minus 5y equals 1. And to solve for the 5y, we subtract the 6 from both sides. So negative 5y equals 1 minus 6 is negative 5. Divide both sides by negative 5. We're going to come up with y equals positive 1. Alright, I'm going to get some more space right here, and we'll work on the next one. Let's plug a negative 2 in for y. So I plug in a negative 2 in, I'm going to have 3x minus 5 times negative 2 equals 1. So that's going to give me 3x, negative 5, and negative 2 multiplied to a positive 10 equals 1. To solve for x, we're starting by subtracting the 10. So that gives us 3x equals negative 9, and divide by 3, both sides. Gives us an x value of negative 3. So this one's going to be negative 3, goes along with the 2 value of y. Alright, and unfortunately I have to erase my work one more time so that I can pick something else and plug it in for x or for y. We're going to go ahead and find one of the zeros because 0 is usually the easier number to plug into an equation, and it's also going to give us a marker right on one of the axes, which is something that's a good reference for graphing. So it doesn't matter if you want to find the x-intercept or the y-intercept. I'm going to go ahead and find the y-intercept because I'm going to plug in a 0 for x. So if I plug in a 0 for x, I have 3 times 0 minus 5y equals 1, or just negative 5y equals 1. And then if I divide both sides by negative 5, we'll come out with y equals 1 divided by negative 5 is negative 1/5. So the ordered pair is 0, negative 1/5. Or when I go ahead to graph this, it's going to be nice to know that negative 1/5 is about negative 0.2 in decimal. So let's graph our ordered pairs. Ordered pairs are 2, 1, negative 3, negative 2, and 0, negative 1/5, or negative 0.2. So it's actually very close to 0 compared to 1. So negative 0.2 is about there. Those do all appear to line up, so let's get a ruler and go ahead and connect them. Once again, making sure your line goes through both sides of the graph, and you can see that it does hit all 3 ordered pairs. The green one's not really showing up right there. Let me draw it again on top of the line. For the next part, we're going to compare linear equations in 1 and 2 variables and describe the solution of each. So if I have a linear equation in 2 variables, the solutions are all ordered pairs on the line. And if I have a linear equation that only has 1 variable, I'm going to get 1 number for an answer. So what is the connection between the equation in 2 variables, y equals 2x minus 3, and the equation 5 equals 2x minus 3? Let's draw a sketch. So what I want to do when I draw my sketch is to draw this equation. Now this is going to be a rough sketch, so I don't know any scaling. I'm going to make my own real quick. I know my y-intercept is at negative 3, and that my slope is 2, which is 2 over 1. So I can go up 2 over 1, up 2 over 1 to get a couple ordered pairs, and we're going to connect those for a quick sketch. So that would be the graph of y equals 2x minus 3, roughed out, and the connection between 5 equals 2x minus 3 and y equals 2x minus 3 is that this could be solved by finding out where 5 on y intersects the graph and looking for the x value. That x value would solve this equation. That would be the one ordered pair out of all of the ordered pairs on this line that solve this one variable equation. That's the connection between the two. A linear equation in two variables has infinitely many solutions, represented by all the points on the line. A linear equation in one variable has one solution in most cases. There are rare cases where it can have no solutions or infinitely many solutions.